Okay, this recording is on using the strategy of greatest common factor to factor a quadratic. So just a little history before we actually start using the greatest common factor strategy, and that is that think about factoring like division. We have factor 1 times factor 2, and sometimes times factor 3 or 4 or 5. It doesn't matter, but we have a whole lot of factors that we multiply together, and that results in a polynomial. And in this case, because we're dealing in this chapter with quadratics, it's usually of the form ax squared plus bx plus c. So most of the time they're going to look like that. But keep in mind that sometimes maybe they don't have a linear term, or sometimes maybe they don't have a constant term. So they could have two terms in them, like those two do, or they might have 3 terms, like this quadratic does. Okay? And so there are some very specific strategies for just quadratics, but greatest common factor is for any polynomial, and it's always the one that we start with. Okay? Because we're trying to take the polynomial and we're trying to figure out what factors did we multiply together to get that. Okay? And so when you're thinking, always start with greatest common factor. And what is greatest common factor? I always think about it like reducing. Like when you're reducing a fraction, you're trying to make something smaller and easier to use. So what you're going to try to do is you're going to try to divide out the greatest number you can from every single term in that particular polynomial so that you can make it smaller and easier to deal with. So if we're thinking about it like in terms of reducing, it's just like if you had a fraction 12 over 8 and you wanted to figure out or reduce that fraction, you would find the greatest number that you could divide it by. So that's your greatest common factor, 4. And then you divide out the 4, so 12 divided by 4 is 3, and 8 divided by 4 is 2. And then this is the other factor. So what we're saying is, if you multiplied the factor times the greatest common factor, you would result in the 12 over 8. You would be right back where you started. So with factoring, we're starting here, and we're trying to figure out what are those factors. Okay? So look at the example given to you right here, 6x plus 4. And we're going to ask ourselves the question, what can we divide both of those terms by evenly? And the answer is that we can divide them both by 2. So you actually show the division. You show that you're dividing every single term by 2. And then you actually complete that division. So you do 6x divided by 2 and you get 3x. And then you do 4 divided by 2 and you get 2. But notice how you write your answer. Whatever it is that you divided by, you put outside your parentheses. That is your greatest common factor. Okay, so this is your greatest common factor. It is 2. And then what's left is what we call the other factor. So this is the other factor. If I multiplied 2 and 3x plus 2, in other words, if I distributed that 2, multiplied it by both of the things inside the parentheses, I would get 6x plus 4. So those are the two factors that multiply together to give me 6x plus 4. Let's try that with the other examples. What would you divide out of those two terms? So you're going to ask yourself, is there a number I can divide them both by evenly? The answer is yes, it is 7. But then you're also going to ask yourself, is there a letter that you could divide out of each of those evenly? And the answer again is yes. I can take at least one p away from each term because they have, all of them have at least 1 to give. So I'm going to take 7p out, and so I'm going to write that as my answer because that's my greatest common factor. And then what's left is going to be the other factor. So 7 divided by 7 is 1. I had 2 p's and I took 1 away. It left me with 1p. 21 divided by 7 is 3, and p divided by p is 1. So my two factors are 7p and p plus 3. Let's look at example 2. Is there some number that you could divide every single term by evenly? The answer is yes, it is 3. And then, is there some letter you could divide all of those numbers by evenly? The answer is no, and the reason is that the third term, 18, does not have a letter factor, so you cannot take an x away. So I'm just going to write down my greatest common factor of 3, and then in parentheses I'm going to tell what's left. 9 divided by 3 is 3. I can't do anything with the x squared. 3 divided by 3 is 1, so I have just 1x left. And then negative 18 divided by 3 is negative 6. Let's look at number 3. I can divide them both by at least 2 because I know they're even, and I would say more, and maybe you would say 3, and I would say, oh, even more, and then you would perhaps say 6. That is the greatest number that you could divide them both by evenly. You always want to choose the largest. 12 divided by 6 is 2x. 6 divided by 6 is 1. Be very careful not to tell me that it's gone, that it cancels out, because it doesn't. Anything divided by itself is equal to 1, and 1 is definitely a placeholder. The answer here is not 0. It doesn't go away. The answer is 1. So you do need to write minus 1. Be very, very careful of that. It's a very common mistake made. Students will often just cross those out and say, yep, those are gone. They cancel. They do cancel, but they're equivalent to 1, and you can't just ignore that. All right, what are we going to divide these both by? The answer is 2w. That is my greatest common factor, so I put it down. 4 divided by 2 is 2. I have 2 w's. I take 1 away, leaves me with 1. And again, here's that same case. Anything divided by itself is equal to 1. So 2w divided by 2w is equal to 1. They're not gone. They're equal to 1. So write plus 1. All right? So that is greatest common factor in a nutshell.